Okay, so let's start with the discussion of differential equation. So first, let's see the definition of the differential equation. So a differential equation is a mathematical equation that relates a function with its derivatives. So what does it mean? So differential equation is a mathematical equation, okay, that relates a function with its derivative. So it represents a relationship between the dependent variable y and one or more independent variables, along with the rates at which the dependent variable changes. So you will better understand this if you see the general form of the differential equation. So it is a mathematical equation, as you can see here, and it here you will see x, which is an independent variable. We know that suppose phi is equal to x square. So this is a independent variable and this is a dependent variable. So here you will have an independent variable, a dependent variable, as well as you will have the derivatives like first derivative, second derivative, then nth derivative. So you can see the first, second, third, similarly nth derivative with respect of y with respect to x. So these types of equation is called as differential equation. So now you will be more clear with this, a mathematical equation that relates a function with its derivatives. Okay, so if you see the applications of differential equation, so it is widely used to model the natural phenomena in physics and engineering. For example, if you see the fluid mechanics, so we have seen that Navier-Stokes equation, then other types of Reynolds transport equations. So there is a very massive use of this differential equation. Then in heat conduction also, we saw how the heat flows in conduction, convection. Those equations you will use the differential equation. Then in population growth, those types of things. Then in chemical kinetics also we see the application of differential equation. Then in electrical engineering also we know that RC circuits and many more. It is endless. So these differential equations are used to model natural phenomena in physics, engineering, and most of the things in other places also. So now let's discuss the types of differential equations. So basically there are two types of differential equation. One is the ordinary differential equation, that is called the ODEs, and the second is the partial differential equations. These are called the PDEs. So what is the difference? So in ordinary differential equations you have only one independent variable, and in partial differential equations you have multiple independent variables. So that's the difference. For example, if you see here, you will have only one independent variable, only one variable is y and one x. So here one independent variable and one dependent variable. But here if you see, here you have you have multiple independent variables. Like you have one variable k, one variable u, t, no, then x. So you can see multiple independent variables. So sorry, k is the constant. Here the multiple independent variables are u, t, and x. So if you take one is dependent, then other two are independent. So now let's discuss what is the order and degree of a differential equation. So what does order means? So order, if we define the order of a differential equation, so order is the highest order of the derivative. And what is the degree of a differential equation? So it is the power of the highest order of the derivative. So it should be free from radicals and fractions. So why this is important, we will discuss this. So you should make sure that this power of the highest order of the derivative should be free from fractions and radicals. It should be whole number, a natural number type. So for example, if you see this differential equation, so here we see we have dependent variable, then independent variable, then we have derivatives, first derivative, second derivative. So this is the a differential equation as we saw the definition. And if you see the order of this differential equation, so order should be highest order derivative. So here this is the first order derivative and this is the second order derivative. So this is the highest order derivative. So your order will be equal to 2. And if you see the power of this highest order derivative, it is 1. So your degree will be 1. So that's how we find the order and degree of a differential equation. So now let's discuss two problems where we have to find the order and degree of the given ordinary differential equations. So for example, this is the first differential equation. If you see here, the highest order is the second order derivative. So here your order is 2 because it is a second order derivative, and your power here is 1. So in the first question, our order is 2 and degree is 1 of this differential equation. If you see the second question, so here you will see that this is a fraction, and I have already told you in the definition of differential equation that it should be free from radicals and fractions. So here if you see, first we have to get rid of this fraction and radical. So what we will do, so take cubing both side, so it will give you 1 by d squared, here 2, and you cube both side. So this 1 by 3 will go this side on the RHS side, and you will get this. So now let's find the order and degree. So if you see the highest order, so highest order is this, here you get, which is the second order. So your order is again 2, and if you see the power of this order, so if you we know that when we expand this in a plus b whole square form, so you will get a square in this. So your, like, if you see the power of this highest order derivative, it will give you 2 again. So because you know this expansion, so this will also become, its power will be 2. So we know that the highest order derivatives power is the degree of the differential equation. So here your degree will be 2. So that's how you find out the order and degree of a differential equation. Okay.